Here's a question for you. If you shine a light on a coin that's hanging in midair, what do you think its shadow will look like? Do you think it would have a bright spot right in the middle of it? Because it would. It might seem counterintuitive, but 19th century physicists thought so too when they tried this experiment. In fact, in 1905, Einstein described light as photons, but later he added a twist to the story where he treated light as a field of continuous waves. So why is that? Things like waves and particles couldn't be more different. It's apples and oranges. But as it turns out, things like light and electrons can't really be confined to one state of existence, and that is what we call the wave-particle duality. To understand more the quantum behavior of light, there's an experiment that consists in setting up a screen with two slits in front of a wall and shooting a stream of bullets through the slits. In this case, we notice that the bullets either bounce off or go straight into one of the holes to pile up behind the slits in two heaps. Then, we consider the same experiment with water waves, which shows an interference leading to regions in space where the wave disappears and others where it becomes stronger. All of this brings us to the double slit experiment, and to understand it, we have to go way back to the days of Sir Isaac Newton. Based on his own experiment, he decided that light was more like a particle. But 7 years after his death, another scientist, Thomas Young, came to believe that light behaved like a wave. His double slit experiment attempts to look at what happens when light passes through a pair of slits, and this is what he found. As you can see, there is a band of light spread across the screen, or as we call it, an interference pattern. So here we can observe a central bright spot, and then a dark one, and so on. But wait a minute, if light is a particle, then why doesn't it exhibit this property? What about Einstein and photons? Physicists set up a light source that emitted one photon at a time, but after a while of observation, the same interference pattern was seen. Physicists were completely baffled by this. So, they decided to peek and see what actually happened by putting a measuring device. But the quantum world is far more mysterious than they could have imagined. When they observed, the photons were back to behaving like particles. They decided to act differently as if they were being watched. I know, it sounds ridiculous, but it's actually true. It's called the observer effect. By measuring the outcome, we physically change everything. At this point, the whole problem gets very difficult to get your mind around. And as for reality, I think Professor Feynman has the last say on that. The paradox is only a conflict between reality and your feeling of what reality ought to be. Our video has reached to an end. My name is Chahla Tarmoun, and I really hope you guys enjoyed it.